Hello, my name is Autumn Haven, and welcome to Super Science Sunday. Today, we are going to be doing the laminar flow balloon experiment. This is a super simple one. It takes very little resources at all, goes very quickly, has very little cleanup, and is very cheap. Now, I advise doing this one outside, which I'll probably mention later, but because it can be a little messy if you do it inside, but simple. Now, to start, you're going to need a balloon, and you're going to fill this up either on a hose or a normal indoor soffit. I apologize. You're going to either want a 12-inch or an 8-inch balloon. I would advise 12-inch because then the rubber's thicker, and it might be a little harder to pop, but it won't pop in your hands when you're trying to carry it. So we're going to fill this up with water, which gladly, I have an example. So we have our example here. This is filled up about, you can see about how big this is here. Here's my hand. Here's how big the balloon is. Yeah, it's pretty darn full. So now, you're going to want to dry it off, or you're going to put your tape. And now, thing's about to roll. Now, you're going to want to cut about 2-inch long pieces of tape. I'd advise you can do Scotch tape, electrical tape, duct tape. I like packing tape. It's thin, see-through, sticks really well to this rubber. It's really nice. So, a latex, you could say. It's a latex balloon. Put it there. Now you're gonna put one parallel about 1 centimeter above it. So I hate moving this thing. It's terrifying. Especially since I'm in the basement. If this water goes everywhere, it's gonna be moldy. So you'll see, you might be able to see, the little piece of tape is right here, so you're gonna want to put your next one right here. Right there. If I can get the tape. It's the only problem with packing tape. If you lose it, then it flattens out to the rest of your packing tape, and it's really not good. Okay, now I'm going to put it parallel, about 1 centimeter. Doesn't have to be exact. Alright, try to get them as flat as you can be in the edge. Now we're going to do the exact same thing sideways, so that when they intercept everything, it makes a tiny little centimeter by centimeter square in the middle of there. If I can find the tape! The edge of the tape! I'll cut this out of the video. Alright, now, getting the last piece of tape on, and you'll see we should have 1 centimeter by centimeter square right here. You might be able to see on the camera, you probably won't be able to, but it should be about that big. And you're going to, for later, which I didn't add the list here because it's unsafe to carry around knives downstairs, you're going to either want a pair of really sharp scissors, really sharp pointed scissors, or a knife for later. Now, I'd advise bringing a bowl, because it's easier to carry a balloon with water in it in a bowl than just in your hands, because if your hands are just going to slip right through. So, a bowl. And then I'd advise either carrying this outside or having it on a concrete slab or something. I don't know, just a place you can collect water. Now, we are going to go outside, meet you out there. Alright, so now we are outside. I would advise doing this outside because if not, you'd have to aim to make sure your flow is going directly in a bowl inside, and if you miss, it's a large mess to clean up. So this is about our 4th, 5th try now. After a lot of bad misinformation, and one successful test run that we didn't film, this is going to be our last try. So now what you're going to do is take your scissors, your knife, whatever it is, X-Acto knife, and put it right in the middle of your little square and pop the balloon. And that's actually really good results. And you'll actually see right here, it looks like it's not moving. It looks like it's just crystal. That's what a true laminar flow is. Yeah, right about Here. Well, now that it's almost out, now you can see the turbulence starting to happen here. It's like shaking. And we are out. There we are. Now if I kind of press on it, I might be able to... Yeah, you can see again getting a little bit of it there, but it's really turbulent because, you know, my hand is messing with it. But, yeah, so that's about it. Thank you for watching this video. Your explanation will be right after this cut. How fluid flows can be divided into two different ways: laminar flows and turbulent flows. Laminar flows occur when fluid flows in an infinitesimal parallel layers with no disturbance between them. In laminar flows, fluid layers slide in parallel with no eddies, swirls, or currents normal to the flow itself. That's why it is so crystal clear when it comes out of the balloon, and it looks like it's not even moving at the base. This type of flow is also referred to as a streamline flow because it's characterized by its non-crossing streams. Now, if you do this experiment incorrectly and the water starts to spurt and sputter and shift and move and it doesn't look perfectly clear at the base, then you have a turbulent flow. Unlike in a laminar flow, turbulent flows undergo irregular fluctuations or mixing and turbulence, which is why it looks like it's constantly moving, can be so unpredictable. Now, thank you for watching this video. I hope you enjoyed your laminar flow. They're super simple. I've done it like 4 times. I might have mentioned it outside, but that took me like 4 tries testing with this experiment before, you know, I actually got the right try to teach you guys. Also, quick shout out and thank to my sisters and my mother. If you heard when the laminar flow actually worked, if you heard a woohoo in behind the camera, yeah, it was my sister filming. She found it very exciting when it actually worked. So thank you to them for helping me. And thank you to my family for letting me do this. And finally, thank you to you for watching this video. Also, this is a new camera and mic system. This is actually my mom's phone.